Okay, probability with the fundamental counting principle, permutation and combination. In this section, we're going to compute the probability using the permutation and combination formula we already know from previous sections. So there is no new formula, just the problems. Let's look at some problems. Question number 1. Maria, Ian, and Larry and Kim, 1, 2, 3, 4 different people, have all been invited to a dinner party. They arrive randomly and each person arrives at a different time. In how many ways can they arrive? Because there are 4 people, so there are 4 factorial ways. First person could be anyone from 4, second person could be anyone from 3 choices. For the third one there are 2 choices, and the last one would be just 1. So 24 different ways to enter the party. In how many ways Maria arrived first and Kim last? So out of these 4 people, the first position is fixed Maria, last position is fixed Kim. The only possibility is the changes happens here. Second position, if 2 of them are gone, the second position would be anyone from 2, and third position would be anyone from the last one, so 2 times 1. So there are only 2 possibility to have that type of entry. And what is the probability of that? It's a 2 out of 24. So if you simplify that, 2 out of 24, that's the probability. But they won't answer in fractions, so we have to simplify that. It would be 1 out of 12. A group consists of 4 Democrats and 5 Republicans, so total 9. So 4 Democrat and 5 Republican, total 9. We would like to find out in how many ways can 4 people be selected from this group. So we have to find out what is the combination of 4 out of 9. It's a 9 factorial divided by 9 minus 4 is 5 factorial, 4 factorial. It's a 9 times 8 times 7 times 6 times 5 factorial, 5 factorial. Remember, 4 factorial means 24. So multiply this and then divide by 24, which is 9 times 8 times 7 times 6 divide by 24. 126 different ways you can make a group of 4 people out of 9. The number of ways to select 4 Republican from the group of 5 Republican. It's a combination of 4 out of 5, which is 5 factorial divided by 1 factorial, 4 factorial, which is 5. If you simplify this, it's V5. So there are 5 different ways to choose 4 Republican from 5 Republicans. So what's the probability of, out of this 100, we are trying to pick 4 people. What's the probability of having all 4 of them are Republican? So there are 5 cases where all of them could be Republican out of 126 cases. So it's a 5 out of 126. You always have to simplify this. If it's not simplified, then the answer could be wrong. So you have to simplify this. Okay, let's do this one. A box contains 15 transistors, 4 of which are defective. If 4 are selected at random, find the probability of the statement below. All are defective. What's the probability of, if you choose out of 15 transistors, so there are 15. Out of 15, 4 of them are defective and 11 of them are non-defective. So there are 2 different groups, non-defective and defective. So if you choose 4 out of these 15, what's the probability that all of them are defective? So first of all, how many different ways we can choose 4 out of 15 transistor? So the total number of ways can be calculated by using this formula. It's a 4 selection out of 15 is equal to, that is the total number of possible cases. 15 minus 4 is 11. 4 factorial, which is 15 times 14 times 13 times 12 times 11 factorial divided by 11 factorial times 4 factorial. This is gone. So if you just multiply 15 times 14 times 13 times 12 and then divide by 4 factorial, which is 24, that's the total possible ways to choose 4 transistor out of 15, which is 1365. Out of 15, you can choose 4 of the transistor in this many way. Now, out of 15, how many so in out of 15 there are only 4, all are defective. Okay, 4 defective pieces. So how many different ways we can choose 4 defective from 4 defective? So the maximum is 4. We can choose 4 defective pieces out of 4 is by just only one way, because that's a one way. This is only one way. So what is the probability of getting all the defective pieces out when you make the selection? It's a 1 out of 1365. 1 out of 1365. That's the probability. And what about none are defective? If you go back here, how many different ways we can choose 4 non-defective out of 11? That is what we need to find out. So 4 non-defective out of 11 can be chosen using this formula, which is 11 factorial divided by 11 minus 47 factorial 4 factorial. If you do this math, it's 11 times 10 times 9 times 8 times 7 factorial 4 factorial 7 factorial. Cancel out. Just do this. 11 times 10 times 9 times 8 divided by 24, because 4 factorial means 24. So there are 330 different ways you can choose 4 of the transistor where all of them are non-defective, and this is the total number of ways to make the selection. So 330 out of 1365. So that's the probability. So 330 out of 1365. Okay, so is there any common factors? Yes, this is divisible by 3, so it's a 3. It's a 110 divided by 455, and then it's also divided by 5. This is 91, so it's 22 out of 91. Keep in mind, your answer is supposed to be a fraction, and you need to simplify your answer. That's the only thing you have to be careful here. Okay, last question. A hand consists of 4 cards from a well shuffled deck of 52 cards. Look at here. This is 52 cards. There are 4 different suites, 4 different colors, and different cards. Now the question is, find the total number of possible 4-card poker hands. So 4 out of 52, what is the total number of possibility? So that's the combination of 4 out of 52. That's the formula you need to use, which is 52 factorial divided by, the order doesn't matter. So 52 minus 4 is 48 factorial 4 factorial, which is 52 times 51 times 50 times 49 divided by 4 factorial, which is 52 times 51 times 50 times 49 divided by 24. Remember, this 48 factorial and then 48 factorial would be cancelled out, so it's a 270,000 725 different ways to choose 4 cards out of 52 cards. 270,725 different ways to choose 4 cards. A red flush is a 4-card hand consisting of all red cards. Find the number of possible red flushes. So since there are, 26 red cards, this hearts and diamonds, they are red. So 4-card hand flush means the how many ways you can choose 4 red card from 26. So 4 cards from 26. This is the way, which is 26 factorial divided by 26 minus 4 is 22 factorial divided by 4 factorial, which is 26 times 25 times 24 times 23 divided by 4 factorial. We can use the very same idea. Just multiply 26 times 25 times 24 times 23 and divide by 24, because 4 factorial is 24. It's a 14,950 different ways. 14,950 different ways you can have a red flush. So find the probability of being dealt a red flush. The probability is this many cases out of this many cases. So 14,950 divided by the total cases, which is 270,725. You can have decimal answer round to the 6th decimal place, which is 0.055 0.05522. So 0.05522, and then after that it's a 0, so you don't have to round it. Okay, that's all for this section.